Okay, we're taking a look at 2013 question 3a. So we have a particle is projected from a point on horizontal ground. The speed of the projection is u and the angle alpha to the horizontal. The range of the particle is r and the maximum height reached is r over 4 root 3. Show that r equals this stuff and find the value of alpha. So in our diagram here, I've drawn it just a little bit ahead of time, we have that r is the range, obviously, which is shown there on the x or on the y-axis, whichever way you want to call it, and u is the projection of the particle at an angle alpha. And I've also marked in there the height which they gave to us. So first off, what we've got to do, as we always do, is we break it into two directions, so the I and j. So I'll talk at ui, vi, ai, SI and TI. And we're going to find the time in both and then relate them. So what we do know is we know that S, the range in the I direction is just R. That's where we're talking to the very end. The acceleration in the I direction is 0 because it's not accelerating in the I direction. Just remind yourself, I direction is that way. So in this case, we can actually just use Dad's silly triangle for these. We don't need to mess around with this kind of business. So using Dad's silly triangle, okay, I can relate distance, speed, and time. We know the initial speed is going to be, if I break this triangle up, if this is u, sorry, that's a u, but you get my pen is not great, then this side here is the adjacent, so it's going to be, I'll call this u in the I direction. So ui is going to equal u, I'll get some u cosine alpha. So we've got the ui, the time is t, we don't know anything else, and the distance is r. So we're kind of stuck at the moment because we need to have a bit more. So at the moment I'm going to have, I don't have enough information in the I direction. So we'll take a look instead at the j direction. So uj, oopsie doodle, uj, vj, aj, sj, and t. So we know the time, we know the height when it lands is 0. And just think about that. How much has it changed from the beginning here to the end? It hasn't raised any height, so it's 0. Now we need to make our initial velocity in the j direction and work out our acceleration. So there the particle is. If you hear a baby screaming, I apologize, not much I can do about that. uj. So uj is going to be, because it's the opposite the angle, it's going to be u sine alpha. So we have our uj. We have a, that's going to be minus g, because it's going down by gravity each time. So let's get t in terms of u, a, s, and t. So I'll just write this here, u sine alpha. Okay, cool, so I don't need this over here, just doubling up. So we're going to use, what equation uses u, a, s, and t? That would be s equals ut plus a half at squared. So I'll write it here. Deadly. So our s is 0. Our u is u, because remember this is uj, so it's u sine alpha t minus a half g t squared. Okay. Next point, we're going to factorize. So I'm going to say t goes into both of them. So u sine alpha minus a half gt. Okay, that means that either t equals 0, which it does, or u sine alpha minus a half gt equals 0. So basically, just to remind yourselves, either this equals 0 or this equals 0. So rearranging the second one, we get, I'm going to say minus a half gt equals minus u sine alpha. The minuses disappear. I get gt equals, 2u sine alpha. Finally, t equals 2u sine alpha all over g. So I now have, why am I doing this? I now have t in terms of alpha and g. Now I can go back to this guy here and plug some things in, because I now know that t is 2u sine alpha over g. So let's see what we have. We've distance, speed, and time. So it doesn't really matter how we do this, but let's say the distance. Yeah, well, they asked us for the range. So distance equals speed by time, s by t. So the range, r, is going to equal, my speed, not just be careful with the S there, that's my speed I'm talking about here. So my speed in the I direction was this guy that we found earlier. So my speed in the I direction is u cosine alpha times my new time. And my new time is 2u sine alpha g. 2u sine alpha over g. Okay, putting that all together, I get my R to be 2u squared cosine alpha sine alpha all over g. Now let's just go back to the question. Hey, that's exactly what they wanted. And we're done. So that's part 1 done. Hey, happy days. So now part 2. They ask us to find the value of alpha. Now, you might be a bit stuck now going, oh, I don't really know where to go from here. Well, go back to the question. The question said, the range of the particle is r and the maximum height reached, they told us the maximum height. So let's use that information. So at the maximum height, when the height is maximum, what do we know? And hopefully remember that at max height, so at max height, I need to get a new pen, Vj equals 0. The velocity in the j direction is 0 momentarily. So let's look at the information for the max height. Uj, Vj, Aj, Sj, and T. Okay, so the initial velocity is, well, it was what it was. So what was the initial velocity? It was u sine alpha. So it is u sine alpha again. So u sine alpha. Okay, my Vj is 0. My A is minus g. My height is given as or 4 over root 3. And my time, what time does it get to the max height? Well, if you remember, because it's on a flat, the max height has to be half of the time. So we found the time earlier. The time was, bada bing, 2u sine alpha over g. So now our time is going to just be u sine alpha all over g. Done. Okay, great. Let's just plug some things in then. So, well, we can go for, might as well use the v. We've got v equals u plus at. Okay, now is that going to help us just before I get cracking into it? That's going to give me, I can already see, just taking a moment to think about it, things are going to cancel by the looks of that, so I don't think that's going to be any use to me. So I'm probably going to instead, and just look for yourself, you'll have u, which is this guy, take away this guy by this guy, and you can see that they're going to just end up cancelling, giving you 0. So that's why they gave us the range. So I'm going to instead use s equals ut plus half at squared. So I'll get rid of these little, get rid of these dots that I made here, and I'm going to use s equals ut plus half at squared. Great, I'll do it in red now that I'm here in red. So s equals u plus half at squared. So r over 4 root 3 equals u sine alpha minus a half g times, oh, I forgot the t here. So take my time, slow down. I'm going to replace the t with all that stuff that we had before. So u sine alpha all over g. Minus a half g by u sine alpha all over g to be squared. Okay, now we'll probably see some magic in a while. We know what or is. It was given to us. So we have or. So I can take that out, but I'll probably do that in a little while. Just in no rush. I might clean this up first. So what I have is or over 4 root 3 equals, equals u squared sine alpha over g minus a half g, always take your time with squaring brackets just so you don't make a silly mistake, u squared sine squared alpha all over g squared. Now hopefully you can see here that g will cancel the bottom. I did forget a little squared there. See sine alpha by sine alpha, just to show the benefits of not going too fast. Too fast, too furious. R over 4 root 3 equals, this becomes u squared sine, oh my god. Someday I'll invest in a good one of these. Hashtag, you know what gift to get me. Okay, the g's cancel and I get a half of this all over 1g. So basically it's oopsie doodle. It's this thing take away a half of the same thing, right? So what's 1 take away a half? It's just going to leave you with a half. So you're going to be ending up with r over 4 root 3 equals, excuse me, a half u squared sine squared alpha all over g. I'm going to multiply both sides by 4 root 3 just to get rid of that. So I'm going to say it's 4 root 3 u squared sine squared alpha all over 2g. And now I'm going to replace the or. So let's go back to the question at hand. Bada bing, bada boom. It's 2u squared cosine alpha sine alpha g. So 2u squared. Yeah, I need to think about what I just read. 2u squared cosine alpha sine alpha all over g equals this guy. Oopsie. U squared over sine squared alpha all over 2g. Now you didn't have to rearrange. You could have had the 4 root 3 on the bottom there. It doesn't really matter. Now let's just see what things start to cancel and work out. So first off, they've got g on both sides. That can disappear. This 2 is going to go into this, leaving you with 2. Both sides are divisible by 2, so those 2's cancel. The u squareds cancel. And we end up getting then down to here. So cosine alpha sine alpha equals root 3 sine squared. Okay, now the key to this, people sometimes go, oh, I'm a bit lost now. Look, you've got a cosine, you've got a sine, so I feel like this is going to work out to be tan somehow, right, which is cos over sine. So what I'm going to do is I'm going to divide both sides by sine squared. Okay, if I divide that side, I'm going to divide this side as well. This squared is going to cancel with that sine, and you're going to be left with, oopsie doodle, excuse me, cosine alpha over sine alpha equals root 3. Now just check your rule in your log tables. It's not cos over sine. Is it cos over sine or sine over cos? So check your log tables. I believe it's sine over cos, so we need to flip both sides. So I'm just going to cheat that and you can have a moment to think about it. But hopefully you can see that root 3 flipped is 1 over root 3. We now get tan alpha equals 1 over root 3. So alpha is the tan inverse of that, which gives us, quite nicely, 30 degrees. Hoi caramba. Now, that last bit is just playing with maths, right, and having a great time doing it. But really the key here is, did you see that the time is half? It was, 2, so you need to half it. And then really actually you kind of didn't even need to know that the max height Vj was 0. It doesn't really help you too much. Yeah, so that kind of is it. Best of luck. Hope that helps.